morning, students. As we discussed in the previous class about position time graph, where we discussed about displacement time graph, and we found that what does displacement time graph give us the information about? Displacement time graph give us the information about the velocity. We all know these things. I think you have gone through it, and today we'll discuss the second part of the position time graph according to our chapter, that is velocity time graph. Let me tell you what does velocity time graph will give us information. Velocity time graph will tell us about the acceleration, remember. Velocity time graph is today's topic. You please write down velocity time graph, and let me tell you that velocity time graph will give us the information about acceleration, as displacement time graph gives us the information about the velocity. Understand? So in this case, we'll finish this lecture in a very short time. It's not a lengthy one. So if I consider the first situation for velocity time graph, in case of velocity time graph, I will take x-axis and y-axis as we took in the previous case. So in this axis, I am going to express the time. You know this thing, this is time, and this is velocity. Suppose this velocity is going to be your p, and this is t equal to 0, this is t1, this is t2, this is t3, this is t4. Similarly, x let us have this is p1, p1, p2, p3, like that. Now if you find a straight line like that, suppose this is the straight line has been expressed here. So if you find this type of a straight line, what do you understand? If your graph gives this type of result, a straight line parallel to the base, what is this straight line will means that? This will means that the velocity is not changing anywhere. Velocity is not changing. That means at t is equal to 0, velocity was v1. At t is equal to 1, velocity is v1. At t2, velocity is v1. That means time is increasing, but velocity is not changing. Velocity is not changing. So what does this graph will tell us now? This graph, if I make a tangent in this point, as we discussed in the previous class, that this graph will tell us about the acceleration. You can note down that velocity time graph will give information. Velocity time graph will give information about acceleration. Is that clear? Velocity time graph will give information about acceleration. So in this case, if you see here, in this case what is happening, that in this case this particular slope, that means velocity is not changing. Velocity is not changing means what? Velocity in this case is constant. Velocity in this case is constant or not? Velocity is constant. If velocity is constant, acceleration is going to be 0. Is that clear? If velocity is constant, acceleration is going to be 0. That means if you find in this case that this slope in this here, this slope tan theta, if I make a slope tangent in this case, what is this? Theta is going to be what? 0 here or not? If I make a tangent in this point, so theta is going to be 0. If theta is going to be 0, so what does theta will give us? That means the theta, since theta is equal to 0, that means since theta is equal to 0, that means we can write that tan theta is also equal to what? Tan 0. Am I clear? And tan 0 itself is equal to 0. Because if once I draw a tangent in this case, I found an angle between the tangent and the line is 0. So tan theta is give us 0. If tan theta is 0, what I can say that acceleration, that means you can write that what does tan theta will means to us? Tan theta will mean us, this is acceleration. Acceleration A is equal to tan theta. This slope of tan theta will tell us the acceleration. So we can find that acceleration is 0, or you can write acceleration A is equal to dv by dt is also equal to 0. Because since theta is 0, that means this slope, once I got this slope which is indicating us the acceleration, and since their velocity is constant, that means in this case what, the velocity is going to be, in this case velocity is constant. Am I clear? Velocity in this case is constant. Why velocity is constant? Because velocity is not changing only. It is in a constant number. If velocity is constant, then what will happen? If you make a tangent here, then the theta will become 0. And once theta will become 0, tan theta will become tan 0. Tan 0 is 0, we know. And what does tan theta will mean as here? Acceleration. In the previous case, tan theta means for the displacement time graph velocity, but in this case it will be acceleration. Hence acceleration dv by dt is equal to 0. Is this point is clear? So as you can see that velocity is constant, hence acceleration is going to be 0. Okay, if I take the next situation, if I take one more situation in this case, if you find this type of graph, if you find a graph like this, if you find a graph like this, suppose this is the graph, and where this side is the time and this side this is your velocity, this side this is your velocity, this is the origin t equal to 0, this is t1, this is t2, this is t3, same case v1, v2, v3. Now in this case, if you find a straight line that is passing through the origin, this straight line that is passing through the origin like that, in this case what will happen? As you can see, at t1 time velocity is increasing this much, at t2 time velocity is increasing this much. That means what? Velocity is increasing gradually. In this case what? Velocity is increasing or not? Velocity is increasing gradually, but on this case velocity was constant, that is why acceleration became 0. But in this case, since velocity is increasing, as you can write that velocity is increasing. If velocity is increasing, if you make a tangent in this point, if you make a tangent in this point, this tangent will make an angle theta again. If you make a tangent in this point, then also the angle will be same theta. If you make a tangent in this point also, then also the angle is going to be theta. That means no matter in this straight line, wherever you make a tangent, they are going to produce an angle theta that is constant. That means in this case the theta is constant, but in this case theta became 0. So you can write that in this case theta is what? Constant. Theta is constant. Have you understood why theta is constant? Because I have told you in the previous video that in this case if you make a tangent here, angle is going to be theta. If you make a tangent in this point, then also this angle is going to be theta. So that is how the angles are going to be constant. So I can write that tan theta is also constant. So once tan theta is constant, that means what? Acceleration is also constant in this case. That means velocity is increasing, that means acceleration is constant. Have you got it? But in this case velocity was constant and acceleration became 0. So in this case A is equal to dv by dt, that is equal to what? Constant. Is this point is clear? That means acceleration is going to be constant. Now you come to the last video or last diagram of this particular case. If you have a situation like this in the acceleration velocity time graph, suppose this is x-axis, this is going to be your y-axis, and this axis as usual, this is your time t and this is your velocity, that is going to be your p. So this is t is equal to 0, t1, t2, t3. So I have given the nomenclature of it. In this case, if I got this type of straight line, that means what you understand in this case, that velocity is decreasing. What? Velocity is decreasing. So velocity is decreasing means what? You can say that if you make a tangent in this point, the angle is going to be formed somewhere here. This is theta. The most important point that in this case, this theta were less than 90 degree. Understand? In this case, this theta, those are constant, where what? All are less than 90 degree. But in this case, this theta all are going to be what? Theta is going to be what? Greater than 90 degree. Theta is going to be greater than 90 degree. That means you can say that in this case, velocity is what? Velocity is decreasing. Once velocity is decreasing and theta is, all theta is going to be what? Greater than 90 degree. So if theta is greater than 90 degrees, so then what happened? Then theta become what? Theta is negative. If theta is negative, tan theta is also doing the negative. That means then acceleration is also going to be negative. Have you understood this point? So in this case, there will be retardation. Why tan theta is being negative? Because this theta is going to be greater than 90 degree. Once theta is become greater than 90 degree, so tan theta will also become greater than 90 degree. So theta is negative. Why? Because in this case, tan theta is going to be greater than 90 degree. So once tan theta is greater than 90 degree, so tan theta is going to be obviously negative. So once tan theta is negative, acceleration is also going to be negative. But in this case, acceleration is constant. This is all about the acceleration velocity time graph. It's very easy one. You just go through it. Don't take any stress about it. So it's very easy one. Once I am telling it, see, in this case you mind that this theta are greater than less than 90 degree in this case. And velocity was increasing, hence theta was constant. If you make a tangent here, theta will be constant. If you make a tangent here, then also there will be theta constant. Hence tan theta is constant. If tan theta is constant, acceleration is also constant. Hence A is equal to dv by dt is going to be constant. But on the other hand, in this case, as you can see that in this case velocity is decreasing, so I can write velocity is decreasing. And this, if you make a tangent here, this is going to be theta. If you make a tangent here, this is going to be theta. Those all are going to be greater than 90 degree. If theta is greater than 90 degree, obviously tan theta will also be greater than 90 degree. Once tan theta is greater than 90 degree, the value of tan theta will become negative. Hence, acceleration is also become negative. Okay, so this is all about velocity time graph. I think you have understood. And finally, we have finished the graphical representation of basic kinematic terms. And basically of the position time graph, we have discussed displacement time graph and velocity time graph as well. Any doubt, inbox me. I'll try to get back to you. For today, thank you so much. In next class, we will coming with something new. That is the proof of equation of motion. Those we have already found. There are 3 equations of motion. So in the next class, we'll discuss that. Thank you.